The forget gate decides how much of the previous cell state, C sub t minus 1, should be retained. This is the formula. The forget gate is a linear feed-forward layer that takes the previous hidden state and the new input x sub t as input. The output logits of the layer go through a sigmoid function. So f sub t is the forget gate output. Here is the equation that illustrates how the forget gate output is constructed. This WF contains the weights for the forget gate. So it is a weight matrix that connects the input with neurons. Notice that this WF is multiplied with a concatenated vector. The vectors that are concatenated are the previous hidden state, h sub t minus 1, and the new element in the actual input sequence, x sub t. This x sub t is the embedding vector of the current word if we are considering words coming in a sequence. The concatenated vector connects with the neurons of this linear layer. The number of neurons of the forget gate is equal to the length of the cell state vector. That is because we will multiply f of t with the cell state vector. This is cell-wise multiplication, so their lengths must be the same. That means the number of neurons we have in this layer must be the same as the length of c sub t minus 1 or c sub t. Bf is the bias term for the forget gate. The length of this bias vector is equal to the number of neurons we have here in the forget gate. That means number of bias values or the length of this bias vector would be the length of this c sub t or c sub t minus 1. This sigma function is indicating the sigmoid activation function. That means the forget gate's logits pass through this sigmoid function, and hence f of t is a vector that contains probabilities. That means each cell of f of t will have numbers between 0 and 1. Notice here that f sub t is multiplied with c sub t minus 1. This is a cell-wise multiplication between these two. A link to the full video is provided in the description or in the comment. Thank you.